Hi students, friends, good morning to all. So this is our new session. This is the first session of your advanced technical training program. In this particular ATT program, I am going to deal with the subject fluid mechanics. Okay. So here we are going to learn we are going to revise the concepts of the fluid mechanics, and we are going to learn how to solve the examination questions. We are going to cover the questions which have been asked in various examination, competitive examination like GATE, then IES examination is there, Indian Engineering Services, and then ESE, that is Engineering Services examination, and many others competitive examinations are there. So here we are going to revise the concepts of the fluid mechanics, which you have already learned in the last year in the third semester, right? So we will revise the concept, and we are going to solve the problems, basic problems, as well as the problems which have been asked in examinations. Okay, problems as well as multiple type questions which have been asked in examination, that we are going to learn. Okay, so let us start. So here we are going to study these concepts of the fluid mechanics as we have studied the different units as per our syllabus. Okay, so unit by unit we are going to revise the concepts, and we are going to solve the various types of questions which have been asked in examination. Okay, is there any problem? Is there any doubt? So if you don't have any kind of query, doubt, we will start directly. We will move directly into our main content of the first lecture. So the fluid properties is the first and most important point, or the concepts, fundamental concepts of the fluid mechanics. Unless and until you know the various properties of the fluid, we are unable to understand the other higher concepts. Okay, so first of all, basics or fundamental concepts we should know, we should thorough with it. Okay, because of that, we will understand, first of all, we will revise the concepts of the fluid properties. What are the various fluid properties which are useful, physical properties which are helpful for understanding the further concepts from the fluid mechanics? That properties we are going to deal with right now. Okay. So very first property where we have studied about the fluid, about the fluids is, it is the mass density. Okay. So here we will study the mass density, this property first. Okay. So before going into this different physical properties of the fluid, so let us revise once again what is fluid. So fluid is nothing but it is the substance which has the capacity to flow, or which shear continuously, deform continuously under the shear force, right? So that is the fluid. So we can classify the fluid in two categories. We can classify the substances into categories, or the fluids into categories, as liquids and the gases. In the liquids, we have different examples like water, different types of oils are there, and in the gases, we have the different types of gases and air, like hydrogen, helium, lithium, oxygen, nitrogen. These are the different types of gases which come under the fluid categories. Okay, air as a fluid. So let us begin with the properties. What is mass? First of all, we should know what is mass, and then we will learn what is mass density. So mass is nothing but it is the amount of matter which is present inside any object. Okay. If you see or if you don't even don't see any kind of object, for example, air is an entity or object which we don't see, but it is an object, and it has certain mass. So mass is nothing but it is the amount of matter present in that particular object. And also, if you consider the one glass of water, and then how much amount of matter is present in that water, that particular glass. So that amount of matter is nothing but it is the mass of that particular object. Okay, here we are talking about the mass of the water in the glass. So now, what will be the mass definition for the mass density? Okay, so mathematically, we have studied this, that what is the mass density. So mass density is nothing but it is the ratio of mass of the fluid to its volume. Okay, So that is nothing but mass density. If you take how we can find out the mass density of any object or any fluid. For example, if you want to find out the mass density of water, how we can find out the mass density of water? So here we can use any method to find out the mass density of the water. We can there are different ways we can measure. We can find out what is the mass density of water. Let us say consider what has happened to this pen. This pen is not working. Okay, I will use this mouse. Yes, if you want, if we take 1 liter of one measuring flask, okay, and in that measuring flask, if we take the weight of the empty measuring flask, let it call it as a M1, okay, and then if we take the weight of the other, when the fluid will be filled or the water will be filled in that measuring flask, and then if we take the weight, then we will get the weight M2. Now, if we want to find out what is the weight of the water only, then what we will do? We will subtract this M1 from the M2 and we will get the weight of the water only. And if you divide this volume, divide this weight by the volume here, so you will get there the weight density or mass density. Now here we are talking about the weight, but if it is measured in kg, then it is a mass. Okay, mass per unit volume. So here unit will be 1 liter. Here we have taken the 1 liter. Similarly, you can take the other volume unit, for example, 1 cubic meter, 1 meter by 1 meter by 1 meter. Such kind of any measuring device or container you can take, and you can fill it with the water, and you can find out the initial weight of the empty measuring device. And after filling the water inside this, you can take the another weight. M1 and M2 will be the two weights, and if you subtract them, you will get the actual weight of the water and divide this by the volume of the this particular measuring device. Then you will get the weight of the particular that fluid, weight density of the fluid or the mass density. If the unit is kg per meter cube, then we generally call it as a mass density. And if you multiply that the weight, whatever the weight it has come, if you multiply that weight by 9.81, that is acceleration due to gravity, then it will get converted into the weight. Okay, because we know the relation between weight and the mass. Weight is nothing but it is m into z, right? And if you multiply this weight, whatever the weight, for example, 10 kg weight has come, and if you multiply this 10 by 9.81, then it will be get converted into the weight, and you will get the weight density simultaneously. Okay, so this is the simple way of finding the weight density or mass density of the fluid, any fluid. Now, mathematically, this is the formula: mass of the fluid upon volume of the fluid. For water, okay, for the pure water, if you consider the specific that weight density of the water, we generally consider it as a 1000 kg per meter cube. Okay, for pure water. If you take the seawater, then the weight mass density of that seawater will be different. Okay, but if you take the pure water, it will be mass density of the pure water. We generally consider while solving the problems also we consider this value as a 1000 kg per meter cube, right? So this was about the mass density. So here we have to discuss about the unit of the mass density. In standard unit of system, that is SI system of unit, mass is measured in kg and volume is measured in liter. So the unit for this mass density will be kg per meter cube. Okay, not liter, it is meter cube. So the unit can be kg per meter cube, kg per liter, kg per cubic centimeter. But in SI unit, the SI unit of the mass density is kg per meter cube, right? So now let us discuss about the next physical properties of the this fluid, that is weight density or specific weight. So again, the definition is similar to the mass density. Instead of mass, here we have to consider the weight of the fluid. So the weight density of the fluid, it can be mathematically expressed as small w is equal to weight density, weight of the fluid upon volume of the fluid. Okay. Sometimes some authors use the notation gamma to denote this weight density, and mass density is denoted by the letter rho. Okay. So mathematically, weight density is nothing but it is gamma is equal to weight of the fluid upon volume of the fluid. Okay. So weight is measured in SI system. Weight is measured in Newton, and volume is measured in meter cube. So the SI unit of the weight density will be Newton per meter cube. And just we have seen how to find out the weight density of any fluid, right? And now here, if you want to find out what is the relation between mass density and the weight density, here you can see weight density is nothing but it is mass of the fluid upon volume of the that weight density of the fluid upon weight of the fluid upon volume of the fluid. So weight can be written as mass of the fluid into acceleration due to gravity. On the previous slide, I have shown you the relation, that is weight is equal to, it is nothing but mass into acceleration due to gravity, right? So here I can write here, instead of this weight, I can write here mass of the fluid into small z. So this mass upon volume is nothing but it is the mass density, and this z, if you take it as it is, here we get the new relation between the mass density and the weight density, and the relation is gamma is equal to rho into z. Okay, so this is the relation between mass density and weight density. So all of you must remember this formula, this relationship in your mind. Okay, you have to keep in mind. So if you are having notebook, you go on writing these things, formulas in your notebook, because while solving the problems, you will, if you don't remember the formula or the equation, then you will face the problem. Okay, you will not be able to solve the problem. Or if you are having old notebook, then no problem, you can easily solve it, right? So this was about the second fluid property, that is weight density or specific weight. Next fluid property here we are going to learn, that is specific volume. This particular property, generally it is widely used for the gaseous kind of fluid, those fluids which are gaseous in nature. For them, this specific volume, this term is specifically it is used. So what is specific volume? Specific volume is nothing but it is the ratio of volume of the fluid to the mass of the fluid. Okay, if you see this mathematical expression for the specific volume and the mathematical expression of the mass density, you can see that there is these entities are just reversed. Okay, in the mass density, mass was in the numerator and volume was in the denominator, but here in the specific volume, mass is in the denominator and volume is in the numerator. Okay, so here we can see that if you take this volume here in the denominator, then we will get this expression, mass of the fluid upon the volume of the fluid, and this expression is nothing but it is the mass density of the fluid. Okay, so here we can write specific volume is equal to 1 upon rho. Means in other words, we can say that specific volume is nothing but it is the reciprocal of mass density of the fluid. Okay, so you should keep this thing in mind. So mass density, it is particularly just that quantity or that physical property generally used for the liquids, and specific volume, this quantity is generally it is used for the gases. The reason behind that is in case of the mass density, mass upon volume, the volume of the liquids it is unchanged. Okay, it can be easily changed, or we can say that liquids are incompressible in nature, so the denominator value it will remain constant. Okay, so because of that this property particularly used for the liquids, and in case of gases are compressible, and this volume it will under pressure, the volume of the gases it may change, so this property also will change. Okay, so because of this whole term, that is specific volume, or the mass density, it is going to change. So in any closed system, the mass density of the gases it will not remain same, it will go on changing as per the change in the pressure. Okay, so to avoid such problem, the scientists or the engineers, they have considered this property, because mass is an entity which cannot be changed. Volume can be changed, but mass cannot be changed. Mass remains same. Mass, according to law of conservation of mass can neither be created nor be destroyed. So mass will remain same for the gases, for the liquids, for any other objects. Even though if we increase the pressure unlimited, means in the large quantity, the mass is not going to change. Its volume may change, but mass will not change. So this denominator quantity it will remain constant, and because of this reason, for the gases, the specific volume term it has been used. So what is the unit of this particular term, specific volume? The unit will be, it is the reciprocal of mass density. That is, mass density is having the unit kg per meter cube. Here the unit will be, this is the volume will be measured in meter cube, and mass will be measured in kg. So kg per meter cube, meter cube per kg will be the unit for this specific volume, right? So this was the third property we have seen here, and next one is the specific gravity. Yeah, we have already learned about this specific gravity. So instead of having a one-way communication, even some of the students might be remembering these terms. Okay, they might be remembering the definitions or the mathematical expression for this. So instead of having one-way communication, let me ask the question to you. Let's have an interaction between us, so that it will not become monotonous or you will not get bored. Okay, who can tell me this definition for specific gravity, mathematical expression for specific gravity? Can anyone?
It is the ratio of weight density of liquid to the weight density of water.
Correct. Who has given the answer? Voice is not laudable, so if you speak it once again in a loud. Whatever the definition you have said, I listen it, it is correct. But for the other students, on behalf of other, me, if you repeat this once again, then it will be better. Will you repeat it once again?
It is the ratio of weight density of liquid to the weight density of water.
Okay, correct. So here, for the liquids, the standard fluid is considered as a water. So actual definition of the specific gravity will be, it is the ratio of weight density of the liquid to the weight density of a standard fluid or standard liquid. Okay, and for the gases, the standard for the liquids, the standard fluid we consider it as a water, and for the gases, standard fluid we consider it as a air. Okay, so the definition can be written like this or this also. Okay, and it can be written in terms of weight density, or it can be instead of this weight density we can write here mass density also. Okay, so the questions might have come here in your mind that how this is true for the mass density also. Okay, so we have just now seen that the relation between, okay, before that let me revise this expression. Weight density, specific gravity is nothing but it is the generally it is denoted by letter S. Okay, specific gravity is equal to weight density of the liquid to the weight density of water. So mathematically, in short, it can be written as SL. Okay, SL is nothing but it is the specific gravity of any liquid is equal to weight density of that liquid, gamma L, divided by gamma W. Okay, divided by weight density of water. So in this way also we can write down this expression. Now instead of this gamma L, I can write here rho L into G, right? And for the water also I can write here rho W into G. What is this rho L and rho W? Rho L is nothing but it is the mass density of that liquid, and rho W is nothing but it is the mass density of water. So what is the mass density of water? It is 1000 kg per meter cube, right? Now here in the numerator and denominator there is a small g, it will get cancelled, and here we get the relation for the specific gravity as rho L divided by rho W. So here we can define the specific gravity like this also. It is the ratio of mass density of the any fluid to the mass density of standard fluid of water. Okay, so here now, what will be the mass density of that specific gravity of water? Yes, I want answer from your side.
1000.
I am asking about the specific gravity, not mass density.
1.
Correct. I would ask come one. In the numerator, we will have weight density of the liquid. So here we are talking about the water, right? So weight density will be 9810, right? So if you don't have written, if you have not written that values, so you write down there value of rho W, gamma W, and SW in your notebook. Rho W value is 1000 kg per meter cube. Then gamma W value is equal to 9810 Newton per meter cube. And SW value, now here, that is we are talking about the specific gravity of water. According to the mathematical expression, SW is equal to SL upon, gamma L upon gamma W. Gamma L is nothing but where now we want to find out what is the specific gravity of water. In the numerator, we will have the 9810, and in the denominator, again, it will have the 9810. It will get cancelled, or directly you can write here gamma W upon gamma W, it will get cancelled and you will get the value as 1. The specific gravity having unit. What is the unit of specific gravity, or it is unitless?
Unitless.
It is unitless, correct. Because in the numerator and denominator having the same unit, it will get cancelled and it will not having any unit. So the specific gravity of water will be equal to 1. And one more value we should remember. I have told you that specific gravity of mercury, that is Hg.
13.6.
13.6, correct. So keep in mind this value also, because while solving the problems, we may come across this value. Okay. Now let us solve the problems here. Basic problems we will solve, and let me know whether basic questions have not been asked here on this particular properties. We will solve 1 or 2 problems here from this particular, have a practice for this, and then we will go to the next property. Write down the problem. If the specific gravity of oil is 0.8, what is the specific mass or the mass density, weight density, and specific volume? This is the problem. Vaibhavi, what is the problem? You are unable to make it unmute. Okay, I will check it. I think it is not from my side. Allow participant to unmute themselves. So that option is already checked. Means you can unmute yourself. Are you able to unmute yourself now or not? The question was from the Vaibhavi. No.
Yes, sir. Yes, sir.
Wait a minute. Those students who are facing the problem of unmuting, you just quit the session and then once again join through the link and try like that. If you are unable to unmute yourself, or let me check whether I can unmute you. Where is that? Vaibhavi. Report, post, task to chart, mail. Are you able to unmute now? Vaibhavi? Okay, this session is about to end. After 1 minute, it will end. So once again, you rejoin, and at that time, once again, you will check if there any that problem persist. Okay, solve these problems. Have you solved this one? Here, how to solve this problem? I will. Yeah, where is that whiteboard? See here, what is the specific gravity? It has been given 0.8. So here we can write SL is equal to 0.8, and it has been asked that to find out what is the rho L value, then gamma L value, and what is the specific volume. Okay, these values we have to find out. So now we have learned that formula of specific gravity. So we are discussing about the problem. Here, the specific gravity of the that particular fluid is given, and we need to find out what is the mass density, then what is the weight density of that particular fluid, and specific volume, right? So we have learned the formula of the mass, that specific gravity, and it is SL is equal to gamma L divided by gamma W. Okay, also there is another formula. It can be converted into this formula. SL is equal to rho L divided by rho W, right? So these are the two formulas with the help of which we can find out the value of mass density of that particular fluid and weight density of that particular fluid, right? To get these values, we should know the value of rho W and gamma W. What is the value of rho W? It is 1000 kg per meter cube. What has happened? Yes. And what is the value of gamma W? It is gamma W is nothing but it is rho W into Z. Rho W is 1000 into G value is 9.81, and here we get its value 9810 Newton per meter cube, right? So these two values must be known to you before to solve this problem. Now here we can write down this expression as, take this gamma W here, so it will become SL into gamma W is equal to gamma L. So here gamma L is equal to, what is the value of SL? It is given 0.6 multiplied by rho W value
Eight, sir.
9810. How much it is? SL is equal to
SL 0.8.
0.8. Okay, so it will be, let's write here 0.8, here also 0.8, and it multiply it now both the values. I will multiply it 9810 multiplied by 0.8.
7848.
We got
7848.
1848. Correct. What will be the unit? As it is the weight density, the unit will be Newton per meter cube. Okay, or cubic meter. Similarly, use the another formula. SL is equal to, second formula, it is rho L divided by rho W. Rearrange the terms and you will get here the equation as rho L is equal to SL multiplied by rho W. Okay, SL value is 0.8 into rho value is 1000, and you will get here the value as 800, and unit will be kg per
kg.
meter cube. Kg per meter cube. Okay. Now here, out of these two values, rho W and gamma, rho L and gamma L, you can find out any value first. First of all, you can find out this value. Okay, or you can find this first, and from either this value you can find out the other value also. Okay, instead of writing this formula, for example, in this particular problem we have found this value first. Okay, so instead of going for this formula, we can directly find out the value of rho L by using formula, the relation between rho L and gamma L. Okay, rho L, gamma L is equal to, what is the relation between rho L and gamma L? Gamma L is equal to rho L multiplied by Z. हे आपण वरती बघितलेलं आहे. गॅमा आणि रो मधलं रिलेशन काय आहे? मास डेन्सिटी आणि वेट डेन्सिटी मधलं. Weight density is equal to mass density into acceleration due to gravity. So here you can directly use this formula and you will get the same answer. Rho L is equal to gamma L divided by Z. Means you have to divide this value by 9.81 to get the value of rho L. Okay. Now, once you get this value of rho L, now you can easily find out what is the value of specific volume, because specific volume and the mass density having the relation reciprocal. Okay, so Vs or specific volume is equal to 1 upon rho L, right? So here we can write 1 upon 800, and you will get the answer 1 divided by 800 is equal to, how much it is? 1.25 into 10 to the power minus 3. Unit will be, what will be the unit of this specific volume?
Meter cube per kg.
Correct, meter cube per kg, right? So in this way we solve the problems. I think from this problem your concept or understanding of this 4 properties, it might have get clear. What are the 4 properties? Mass density, weight density, then specific volume and specific gravity, right? Where it has gone, properties presentation. So should we solve one more problem here? This problem, it also require the conversion of units, right? So we will solve this one. Write on the problem. 400 ml of certain liquid, 400 ml of certain liquid weighs 9 Newton 400 ml of certain liquid weighs 9 Newton, to stop, calculate mass density, weight density, and relative density. See here, the weight, that specific gravity, it is also called as relative density. So these things also you should remember, right? So instead of writing specific gravity, here it is mentioned as relative density. So relative density is nothing but in relation to other liquid or other fluid, what is the density of that any particular fluid? In relation to the standard fluid, what is the density of any particular fluid? Okay, that is relative density or specific gravity. This is the problem. Now here from the unit itself, you will come to know that what is this value and what is this value. What is this 400 ml?
Volume.
Volume, correct. So in the given, you can write there given 400 ml. And what is this 9 Newton?
Weight.
Correct, it is weight. It is 9 Newton. Now, how to solve this problem? Who will tell the procedure to solve this problem? Anyone can unmute and tell me, tell all of us how we should proceed to solve this problem. Volume is equal to, how much it is? 400
ml.
Okay. And weight is equal to how much?
9 Newton.
9 Newton.
9
Nine.
Newton. Okay,
Newton.
right. So let me check how many of you remember this, how to solve such kind of problem. Here, we want to find out what is mass density, then what is weight density, and what is specific gravity. These are the three things we need to find out from these given things. Right. Now here the volume is given in ml. I want to convert that volume in SI unit, that is meter cube. Right. How I can proceed here? How I can convert this 400 ml in meter cube? Who will tell?
ml लिटर मध्ये करायचं 1 लिटर इज इक्वल टू 1000 ml असते म्हणजे 400 भागिले 1000 0.4 लिटर येते आणि म्हणजे लिटरचं मीटर क्यूब करताना into 10⁻³
Correct. So I am very much happy to know that many of you still remember that conversion part. Okay. Now 0.4, I want to convert that in meter cube. So I will multiply it by 10 to the power -3, right? So here we can write unit directly here is equal to meter cube. Okay. How that conversion has come? Those students who have forgotten that conversion, I will write here once again. 1 liter is equal to how much ml? It is 1000 milliliter. Milli stands for 10 to the power -3, right? So here instead of this m, I can write here. Now it is milliliter, right? 10 to the power -3. 10 to the power 1000 is nothing but 10 to the power 3 into this milli is nothing but it is 10 to the power -3. Here cancel झालं तर आपल्याला या ठिकाणी काय भेटेल परत 1 liter, right? So here I want to convert this milliliter in terms of liter. Okay, this 1000 can be written as 10 to the power 3 milliliter. Okay, and if you take this 10 to the power 3 on this LHS, then I can write here 1 ml is equal to, now when it will go on this LHS side, it will become 10 to the power -3, or it will go in the denominator. So I can write here 1 ml is equal to 10 to the power -3 liter, right? So now here instead of this ml, what I can write? I can write instead of this ml, I can write 10 to the power -3 liter. Okay. Now, the relation between 1 meter cube and 1 liter. Okay, so how much liter is equal to 1 meter cube? So at that time, I have given one analogy there. If you take, if you made a tank of 1 meter by 1 meter by 1 meter, it will having the volume of 1 meter cube. And if you put water inside this with the help of 1 liter can, okay, and if you go on filling it, it will fill with, it will require to 1000 glasses or that can to add inside this particular container to get it filled. Okay, so 1 meter cube is nothing but it is 1000 liter. Okay, right? Or we can write here 10 to the power 3 liters. Okay. Now I want to hear how much 1 liter is equal to. So I will take this 10 to the power 4 or 10 to the power 3 on the in the LHS side, left hand side. So it will become 10 to the power minus 3 and unit will be here meter cube. So 1 liter is equal to 10 to the power minus 3 meter cube. So here, instead of writing this unit meter cube, that liter, I will write here meter cube. So now I will rub this part for your understanding purpose. I will write here 400. Now instead of ml, I am converting it in liter. So I have to multiply it by 10 to the power minus 3. Okay, into again now liter I want to convert that in meter cube. So once again I have to multiply it by 10 to the power minus 3. Now it will become in meter cube. So here this 10 to the power minus 3 also it can be written as 10 to the power 3 in the denominator, and that is nothing but 0.4 into 10 to the power minus 3 meter cube. Okay, so in this way you should do the unit conversion first. You should learn to do the conversion, and then once you do the unit conversion easily, then the rest of the problem is quite simple. You know the formulae. Yes, anyone want to speak something, ask something? You can unmute and tell. Have anyone solved this one, this problem? What is the value of mass density?
2293.57 kg per meter cube.
2293.
93.57
kg per
meter cube.
Okay. This is the mass density. So here, see, they have given the weight and volume. So first of all, we will not get this value first. Okay, at first we have to find out what is the value of weight density, because we know the formula for weight density as it is a weight of the fluid upon the volume of the fluid, right? And these two quantities are given, weight and volume. So first you will get this value of weight density, and once you get this value of weight density, from the relation between weight density and mass density, you can easily find out what is the value of mass density. Okay, so rho L will be equal to gamma L divided by Z, that is gamma L divided by 9.81, and you will get this value. Now to find out this specific gravity, you can use any one of the formula, that is you can use rho L upon rho W, or you can go for gamma L upon gamma W value. Okay, so out of these two, any one formula you can use, you will get the same answer for this. Okay, what about other students? What is the value of weight density?
Two two five zero zero.
2250
double zero.
Okay, Newton per meter cube.
Meter.
Okay, so now use either this value or this value and find out what is the specific gravity. If you have got it, you can tell it.
2.4 2.29.
2.29.
2.29. This is the specific gravity of this particular fluid. Now, can anyone tell me whether this particular fluid is whether it is lighter than the water or it is heavier than water?
Heavier than water.
Heavier than water.
Correct. By how much amount it is heavier? How much times?
1.29.
1.29.
1.29.
No, see here, you have got the specific gravity of this fluid as a 2.29, right? So it is 2.29 times heavier than the water, because in the numerator, in the denominator, there is 1. That is the specific gravity. 1. It's not 1. Specific gravity is nothing but it is gamma L upon gamma W, right? Now here you are dividing this value gamma L, that weight density of this liquid, by the weight density of water. So it is completely dividing this value. Okay, the volume of both liquids will be same. Okay, let us say 1 liter and 1 liter. So this 1 liter will get cancelled here and here, or I will simplify it. Gamma L is equal to WL into Z upon WL upon volume, and here WW, that is weight of water upon volume of water. So this volume for 1 liter, if we are consider unit volume we are considering here, so this volume will get cancelled having both volume, but the weight will be different. Okay, and now here we are dividing this WL, that is weight of the liquid, by the weight of water. So here, and it has come the value as a 2.29, means this particular fluid, it is heavier than water by 2.29 times heavier than water. Okay. Similarly, if we consider the mercury having the specific gravity 13.6, so here what does it mean? The mercury is how much times heavier than water?
13.6.
Correct. So it is 13.6 times heavier than the water. Okay. So like this, we can derive the conclusion from this value, particular value. And if the value of the specific gravity, if it becomes less than 1, for example 0.8, 0.9, then what we can say, that given liquid is heavier or lighter?
Lighter.
Lighter.
Yes, yes. So it is lighter than the water. Okay, it will float on the water. If you put that particular liquid on the water, it will float. And the liquid having specific gravity 2.29, if we put that liquid on the surface of water, it will not remain, it will not float on the surface of the water. It will sink down and water will float on that particular liquid. Okay, ते लिक्विड खाली जाईल आणि त्याच्यावरती वॉटर या ठिकाणी येऊन स्थिर होईल. Okay, so in this way I think the concept of these properties, it is clear. Now we will move towards the next properties of the fluid. The next and very much important property of the fluid is viscosity. Because why this is an important property of the fluid? Can anyone justify that viscosity is a very important property? I am saying. Can anyone justify this answer? Why it is important so much? This property is very important from the point of finding the head losses. Okay, unit number 4, 5 पुढचे जे unit आहेत आपले major head loss, minor head loss, then viscous flow, then turbulent flow. In that particular unit, to understand that concept, the understanding of the viscosity is very important, because because of this viscosity only, there is the head loss which occurs in the fluid. Okay, when we call the fluid as a real fluid and when we call the fluid as ideal fluid, if you remember, you can do the answer. When we call the fluid as a ideal fluid,
विस्कॉसिटी म्हणजे 0 कन्सिडर करते तेव्हा आयडियल फ्लुइड, आणि ज्यावेळेस
correct. When the fluid viscosity is 0, then we call that fluid as a ideal fluid. Right. So in actual nature, there is no such ideal fluid exist, because every fluid, it has some viscosity, right? And those fluid, if we don't have the viscosity, then there will not be any kind of loss. Okay, head loss त्या ठिकाणी होणार नाही कुठल्याही प्रकारचा. आपण हेड लॉस आपण त्या ठिकाणी फाइंड आउट करतो. हेड लॉस ड्यू टू फ्रिक्शन or head loss due to any other minor losses. Okay, so mainly here I would like to wanted to tell you that this property is very important. So understanding of this property is also very important because of that. Okay, so how we can define the viscosity? How we can define this viscosity in your way? Can anyone tell me the definition for this viscosity term? So here, viscosity is nothing but it is the property of the fluid. So this thing first we should keep in mind. We are discussing about the properties of the fluid. So at the start here, this thing should be kept in mind, that viscosity is nothing but it is the property of the fluid. And what it does, this property, it offers, what it does, it offers resistance to what? To what this offer the resistance? This offer the resistance to the moment of one layer. Okay, this properties, it offers the resistance to the moment of one layer of the fluid over the another adjacent layer of the fluid. Means same fluid. Okay, there are, if we divide this entire fluid in different layers. Okay, if you picturize this total fluid surface, this particular fluid region or regime in different layers, then we may observe that one layer of the fluid is offering, what it is doing, offering resistance to what? Resistance to the movement of another adjacent layer. Okay, for example, if we consider this particular layer, this layer, it is offering resistance to the movement of adjacent layer, means this layer. Okay, just upper layer and just down layer. The two layer on this both layer, this particular layer, it is offering resistance to its movement. Okay, it is not allowing this layer to move freely. Okay, it is dragging back. Okay, so that force, that property of the fluid which offer resistance to the adjacent layer, resistance to what? Resistance to its movement, that particular property is called as the viscosity. Okay, what is viscosity? It is the resistance offered by one layer to the another adjacent layer. That resistance is called as the viscosity. Now, because of this nature of the fluid, viscous nature of fluid, you may observe here such kind of velocity profile. It can be seen in any kind of liquid. Okay, if you see flow through the pipe, or if you see flow through the open channel, okay, कुठल्याही प्रकारचा जर फ्लो असेल, and if you measure the velocity of this fluid at different depth, pipe flow जर असेल तर याच्यामध्ये आपण जर या ठिकाणी पिटॉट ट्यूब ठेवली, and with the help of pitot tube, if you measure the velocity of the fluid at this particular point, then just above it, just above it, just above it, like this. Okay, you will observe that this velocity is not uniform. Okay, ही जी velocity आहे uniform नसते, ही कशी असते? You will observe that velocity is this parabolic in nature. Similarly, in case of open channel also, the velocity of the liquid flowing through any open channel, it is not uniform. It is changing. So what does it mean? At the surface, the velocity will be zero. ज्या ठिकाणी surface, when the fluid comes in contact with any surface, because of this roughness of that surface, the very first layer of the fluid, it will remain intact with the surface. It will having the velocity 0, and the another layer which is above that first layer, it will having some velocity. Okay, and that particular layer, it will be dragged back because of the by the first layer. सगळ्यात खालची लेअर असते ती काय करते, याच्या वरती जी लेअर आहे त्या वरच्या लेअरला मागे ओढण्याचा प्रयत्न करते. ही लेअर पुढे जाण्याचा प्रयत्न करते आणि त्याच्या खालची जी लेअर जी आहे त्याला पाठीमागे ओढण्याचा प्रयत्न करते. त्यामुळे याची पण व्हेलॉसिटी कमी असते. पण जसं वरती हा आपण वरती जायला लागेल तसं तसं काय लागते या ठिकाणी व्हेलॉसिटी ही वाढत जाते. अँड इन केस ऑफ पाईप फ्लो, द व्हेलॉसिटी विल बी मॅक्झिमम ऍट द सेंटर ऑफ द पाईप. ओके, हा कर्व आपला असा दिसतो, या ठिकाणी असा वाढलेला दिसतो मॅक्झिमम या ठिकाणी. अँड बियॉन्ड दिस सेंटर लाईन अगेन दिस व्हेलॉसिटी विल गो ऑन डिक्रीजिंग, कारण या ठिकाणी परत सरफेस आहे. ओके, जसं या खालच्या हाफ पार्टमध्ये सिच्युएशन कंडिशन आहे तशीच ह्या वरच्या हाफ पार्टमध्ये पण या ठिकाणी कंडिशन असते. अँड बिकॉज ऑफ दॅट हिअर यू विल ऑब्झर्व दिस पॅराबोलिक कर्व in case of this particular pipe. Similarly, in case of open channel also, this particular velocity it will go on increasing till the surface, but just near to the surface, again this velocity will go on decreasing somewhat. This is because of the resistance offered by the flowing wind or any other particular resisting force. Okay, and you will observe the velocity profile like this. Okay, so because of this resistance which is offering here, what is happening there? A shear stress it is going to act there. Okay, या ठिकाणी हे जे लेयर्स आहेत वेगवेगळ्या, या लेयर मध्ये शियर स्ट्रेस हा त्या ठिकाणी जनरेट होतो. अँड दॅट शियर स्ट्रेस इट इज डिनोटेड बाय लेटर टाऊ. ओके, तो शियर स्ट्रेस आपण कोणत्या लेटरने डिनोट करतो? टाऊने डिनोट करतो. ओके, दिस इज द टाऊ सिम्बॉल. इन इंग्लिश इट इज प्रोनाउन्स्ड एज टाऊ. Okay, and this shear stress, that scientist Newton, he has observed that after doing various experiments, he has observed that this shear stress is directly proportional to shear strain or velocity gradient, that is du by dy. Okay, and he called this particular law as a Newton's law of viscosity. Okay, या लॉला त्यांनी नाव काय दिलं? न्यूटन्स लॉ ऑफ विस्कोसिटी. Okay, to remove this directly proportionality sign, he has put here one constant, and that constant is called as coefficient of viscosity or dynamic coefficient of viscosity. And he has given a mathematical expression as tau is equal to mu into du by dy. Okay, so this is the mathematical expression that we use to find out the dynamic viscosity, or to find out the velocity gradient, or to find out the shear stress. Okay, if other two values are given, we can find out the remaining third value with the help of that two values. Okay, is there any doubt in this? So in your notebook, just write down this formula: tau is equal to mu into du by dy. These two formulas, mathematical expression, you can write down because these are important for us. Write down these two equations. Tau is directly proportional to du by dy. This du by tau is nothing but it is shear stress, and du by dy is nothing but it is a rate of shear strain. See here, what is that du by dy? It is the rate of shear strain, or it is also called as the rate of shear deformation or velocity gradient. There are three terms or terminologies it has been used for this particular entity du by dy. What are that? Du by dy is nothing but it is a rate of shear strain, a rate of shear deformation, or velocity gradient. What is the unit of this shear stress tau. As you are aware about the term stress, we have learned various types of stresses in the MOS or SOM. What is the unit of stress, or just formula, simple formula for the stress? Stress is nothing but it is force per unit area, right? So the unit will be Newton per meter square, Newton per centimeter square, Newton per mm square. But in SI unit, the general unit is Newton per meter square. Okay. Now here, to get the unit of this viscosity term mu, okay, this is mu, and this mu is nothing but it is coefficient of viscosity or coefficient of dynamic viscosity or simply viscosity. Okay, to get the unit of this term viscosity, what we do, we take this part in the LHS, then you will get here tau divided by this stress divided by strain. Okay, and after simplifying, you will get the unit of viscosity in MKS system of unit. In MKS system, the unit of viscosity is kg of force, kg of force second per meter square. Okay, the force in MKS system, the force is measured, or it is measured in the unit kgf. In SI system, the unit of force is Newton, right? In SI system, we measure the force in Newton, but in MKS system, the unit of force is kgf. Okay, kg of force, right? So this kgf second per meter square, this is the unit, MKS unit. Then CGS unit क्या है? Dyne second per centimeter square. In CGS unit, the force is measured in dyne. Okay, so dyne second per centimeter square. In SI unit, the force is measured in Newton. So unit will be, instead of this kgf, now you can put here Newton second per meter square. So this is the SI unit of viscosity. Okay, now here if you observe Newton per meter square, what is that Newton per meter square? What is the कशाच unit आहे ते? Newton per meter square or force per unit area. It is the unit of stress or it is the unit of pressure, right? Force per unit area or force per meter square. So here Newton per meter square in SI system, it can be written as Pascal. Okay, so this Newton per meter square can be called as a Pascal. So here this SI unit of the viscosity can be called as Pascal second. Okay, so this unit should be kept in mind, Newton second per meter square or Pascal second. Okay, now what is 1 poise? Okay, हे एक unit आहे poise. This should be kept in mind. This conversion has been asked in examination, or they will give the unit as a poise and you need to find out the unit in SI system of unit. Okay, so 1 poise is equal to 10 to the power minus 1 or 1 upon 10 Newton second per meter square. Okay, so this conversion you note down in your notebook. Okay, so now here we have seen the different units. I think I suppose that all of you have written these units and the formula. MKS system kgf second per meter square. SI unit for the viscosity is Newton second per meter square or Pascal second, and 1 poise is equal to 10 to the power minus 1 Newton second per meter square. After that, Newton's law of viscosity, we have studied about this. What that Newton's law of viscosity it says that the shear stress which is generating inside the different layers of the fluid, that shear stress is directly proportional to the rate of shear strain, right, or rate of shear deformation. So that is this particular value, this tau is directly proportional to du by dy, is nothing but it is the Newton's law of viscosity. And if you put that constant of proportionality mu, then we will get this mathematical expression tau is equal to mu into du by dy. Okay, The fluids which obeys the Newton's law of viscosity, they are called as the Newtonian fluid, and the fluids which don't obeys the Newton's law of viscosity, they are called as the non-Newtonian fluid. Okay, on the next slide, you will see there different types of fluids. In that, these are the two types of the fluids will be observed there. One is the Newtonian fluid, another is the non-Newtonian fluid. When we call the fluid as a Newtonian fluid, the fluids which obeys the Newton's law of viscosity. Okay, means what mathematically what can be said here about this? Means the fluid in which the shear stress is directly proportional to the rate of shear deformation. These fluids are called as the Newtonian fluid. The fluid in which the shear stress is not directly proportional to the rate of shear strain or rate of shear deformation, then such fluids are called as the non-Newtonian fluid, right? Now here we have come across one question. It has been asked in IES examination. Okay, Indian Engineering Services. Okay, त्याच्यामध्ये हा विचारलेला प्रश्न आहे. What is the question? Newton's law of viscosity depends upon. These are the options. First option is stress and strain in the fluid. Okay. Then second option is shear stress, pressure, and velocity. Third option is shear stress and rate of strain. And fourth option is viscosity and shear stress. Now you have to give the answer for this particular question. If you understand the concept of the viscosity, you should give the answer to this question. Which option is the correct one?
C.
Option C. Some are saying option C. Anyone? Any other option? Is anyone saying option A? Stress and strain in the fluid? Option B, shear stress, pressure and velocity. Option C, shear stress and the rate of strain. And option D, viscosity and shear stress. Some of the students have said the option C, and this option C is the correct option. See here, what the Newton's law of viscosity is saying, shear stress is directly proportional to rate of shear strain. Okay, this is the shear stress and this is the shear strain. So here, the first option is not correct one. It is talking about the stress in general and stress in the fluid. Okay, strain in the fluid. Stress can be any kind of stress. There are different types of stresses. There are different types of strains. Okay. Particularly here, we are interested about the shear stress or shear strain, shear deformation. Okay. So in SOM, you have studied tensile stresses, compressive stresses, shear stresses, shear strain, tensile strain, compressive strain. The strain which has been generated because of these stresses, they are associated with this particular stresses, right? Now here, if you use this general term, then it may not be the correct one. In second option, see here, first it is talking about the shear stress. So this up to this is correct one. Then it's talking about the pressure, where that pressure has come in this particular term. Are you observing any kind of pressure term here? No. Then velocity. Velocity is there, but it is the rate of change of velocity. Okay, it is not just velocity. This u is nothing but it is the velocity, right? But it is changing with respect to vertical distance from the surface. Okay, so this option is also not correct one. If you discuss about this option D, it may be the students may get confused between this option and this option again, option C and option D, because viscosity. This particular law is connected or it deals with the viscosity only, and there is a term shear stress also. But if you see here in this particular mathematical expression or the statement what we have seen there, whether there is a viscosity term directly. Viscosity is nothing but mu. Is there any mu term here? No. So tau is directly proportional to du by dy. We are talking about this. Afterwards, to have a constant, okay, mathematically, to make it mathematically simple, he has put the constant of proportionality, and that constant is nothing but mu. Okay, but in his statement, whether he is talking about the viscosity, no. What he is saying, shear stress is directly proportional to the rate of shear strain. So shear stress and shear strain, or the rate of strain, these are the two quantities which are involved in this particular law. So the correct option is option C. Is there any doubt in this? See here, this is the answer to this. Newton's law of viscosity. Tau is equal to mu into du by dy. Tau is nothing but it is shear stress, and du by dy it is rate of strain. Next question. Yes, actually this question, yeah, here problem is there. So let us solve this one. Write down the problem. All of you have to solve this one. An oil of specific gravity 0.9 has viscosity of 0.28 strokes at 38 degrees Celsius. What will be its viscosity in Newton second per meter square? Yes. Sanket, option C is for this particular question or previous one? This should be stroke. It has become stroke here. So see here, for the stroke we have written there, one stroke is equal to how much? It is 10 to the power minus 1 Newton second per meter square. Okay. Now they have given here the specific gravity also. Okay.
1 poise is equal to 10 raised to minus 1.
सर ते पॉइंट्स आहे की
Stroke 10 raised to minus 4 येते.
Right. It
Oh,
is
sir.
1 twice is equal to this much. Now here they have given the viscosity in stroke, means they have given us the kinematic viscosity. So actually this problem should be taken afterwards. Okay, so sorry for that. Before that we should know what is kinematic viscosity. Unless and until you remember that formula for kinematic viscosity, it is somewhat difficult for you to solve this problem. Okay, so let us cover that first point and then we'll come back to this question particularly. Yes, this is our next property, not property, it is a unit of the viscosity, that is kinematic viscosity. Okay, so what is kinematic viscosity? Can anyone tell me, if you remember, what is kinematic viscosity? And how it is denoted? What is that symbol we use for denoting kinematic viscosity? Kinematic viscosity is nothing but it is denoted by symbol nu. Okay, this is new symbol. Kinematic viscosity is nothing but it is the ratio of dynamic viscosity to the density of the fluid. Okay, mu is the kinematic. This is the dynamic viscosity. Okay, so mathematically it can be written as nu is equal to mu upon rho. This is nu is equal to mu upon rho. Right. So write down this mathematical expression in your notebook. Kinematic viscosity. Then SI unit of kinematic viscosity. What is the SI unit of kinematic viscosity? If you remember, it is meter square per second. Meter square per second. CGS unit. In CGS, the distance is measured in centimeter. So the unit will be centimeter square per second. The CGS unit, this centimeter square per second, it is also called as Stoke. Okay. 1 centimeter square per second. It is also called as Stoke. Now, if I want to convert this centimeter square in meter square, how I can convert that? 1 centimeter square per second is equal to Stoke. 1 meter is equal to 10 to the power 2 centimeter, right? 100 centimeters are 1 meter. So if I do the squaring on both sides, what I will get here? 1 meter square is equal to 10 to the power 4 centimeter square, right? So 1 centimeter square is equal to 10 to the power minus 4 meter square, right? 1 centimeter square is equal to 10 to the power minus 4 meter square. Now, instead of this, if I put there 10 to the power centimeter square, 10 to the power minus 4 meter square per second. Okay, so here you can see this is the SI unit, and in CGS unit, what is that? 1 centimeter square per second is equal to 10 to the power minus 4 meter square per second, or 1 centimeter square per second is nothing but 1 Stoke. 1 Stoke is equal to 10 to the power minus 4 meter square per second. Are you getting my point? So write down this particular conversion. 1 Stoke is equal to 10 to the power minus 4 meter square per second. Is there any doubt in this conversion? If you don't understand, please tell me, I will repeat it once again. Yes.
No, sir.
Okay, now we will move ahead. This is the question. The SI unit of kinematic viscosity is. So this question was asked in GATE 2001.
A. Option A.
Option A. Correct. Option A is the answer for this. Next question. It is coming like this. For a Newtonian fluid, options 1, 2, 3, A, B, C, D. These are the 4 options. And this question was asked in GATE 2006 and 1995. 2 times this question was asked. And you have to tell me the correct option for this.
Option C.
Option C.
Okay. For a Newtonian fluid, option A is shear stress is proportional to shear strain. Then the rate of shear stress is proportional to shear strain. Shear stress is proportional to the rate of shear strain. The rate of shear stress is proportional to the rate of shear strain. Option C is the correct answer, right? See here, we are not talking about the rate of shear stress. It is just shear stress, right? And so see, you can see all these 4 options are most of the similar options are there. But in first option, shear stress they have given, it is proportional to shear stress. Means first half part is correct, but in second half part, they are talking about the only shear stress, not about the rate of shear strain. Okay. Second half part is the in second option. The first part is wrong one. The rate of shear strain they are writing there. So it is not the rate, because in the denominator there is nothing, right? So there is only one value, that is tau on the left hand side. Tau is equal to du by dy, right? So that option B is also wrong one. Option D, if you see there, again there is a rate of shear stress. So that is also wrong one. Option C, shear stress, that is tau, is proportional to rate of shear strain, that is du by dy. So the option C is the correct option here. Good. Now here we will solve 1 or 2 problems about this, and then we can see the next part from this. Okay. Again, there are a few questions that we will see first, and then we can go ahead. This is also question. Read this question. Newton's law of viscosity depends upon these are the following options.
Option C. झाले सर मगाशी हा क्वेश्चन.
झालंय रे.
It is over, no? I think it is repeated. Okay. So let us solve. आपण ह्याच्यावरती 3 टाइपचे प्रॉब्लेम आपण सोडवले होते ह्याच्यामध्ये FM मध्ये, इंट्रोडक्शन IFM मध्ये. सो यातले 3 टाइपचे जे प्रॉब्लेम आहेत त्यातले एक एक्झाम्पल किंवा 1-2 एक्झाम्पल्स आपण घेऊया, आणि गेट मध्ये अशा टाइपचे कुठले प्रश्न विचारले ते पण आपण या ठिकाणी सोडूयात. ठीक आहे. सो नाव हिअर directly we will solve this problem. So first of all, basic problem we will solve, then we will solve the difficult one from the competitive examination. So this is very basic one. Conversion kind of problem, these are already known to you, how to do the conversion part. Or should we take this one? यातला एखादा घ्यायचा. Okay, directly we will have the problem from this this kind of problem. Second type. Write on the problem. If equation of velocity profile over a plate is, if the equation of velocity profile over a plate is v is equal to 2 into y raised to 2 by 3, in which v is velocity in meter per second, in which V is the velocity in meter per second at a distance of y meters. At a distance of y meters above the plate. Above the plate. Determine shear stress. Determine the shear stress at y equal to 0. At y equal to 0 and y equal to 0.075 meter. Given mu is equal to 8.35 poise. Now here I will mask this one. Yes, all of you have written the problem. So first of all, write down the given things. What is given? Dynamic viscosity is given. Mu is equal to 8.35 poise. So convert that poise in Newton second per meter square. How to convert that? Who will tell me? How to convert? What is the relation between poise and Pascal second?
1 poise is equal to 1/10 Newton second per meter square.
Correct. So 1 poise is equal to 1/10 Newton second per meter square. So divide that value by 10, you will get the SI unit. So 0.835 Newton second per meter square. Then write down the equation V is equal to 2 into y raised to 2/3. Given equation is V is equal to 2 into y raised to 2/3. Now here, what is asked to find? What we have to find out here? Shear stress. Means we have to find out what is the value of tau at y equal to 0. Means here we have to find out two values of tau. That is tau at y equal to 0 and tau at y equal to 0.077, 0.075, right? These two values we have to find out. So what is the equation to find out the value of tau? That is Newton's law of viscosity. Tau is equal to mu into d dy. Now here in this particular problem, they have given, instead of velocity, instead of giving the velocity in terms of u, for the velocity they have used the notation v. So do not get confused in that. So instead of this v, you can write here v also. So mu into dv by dy. This is our mathematical expression to find out the dynamic viscosity, that shear stress, right? But whether this values it has been given in the problem directly, ते आपल्याला दिलेलं आहे का value, rate of shear stress ची value दिलेली आहे का? दिलेली नाहीये. Then what we have to do? First of all, they have given the equation. We have to convert that equation in terms of dv by dy. What the equation they have given us? they have given equation v is equal to 2y raised to 2 by 3, right? Now, if I divide or differentiate this equation with respect to y, what I can write here? dv by dy. Are you getting my differentiation of this equation with respect to y? So dv by dy as a differentiation काय v च dv by dy is equal to 2 into आता हे y raised to 2 by 3 चं differentiation काय येईल 2 by 3 into y raised to 2 by 3 minus 1.
-1.
Correct. So here I can write here this 2 by 2 as a 4 by 3 into y raised to now 2 by 3 minus 1. Now here to make this base same or denominator same, I have to multiply it by 3 and divide it by 3. So I will get here 2 minus 3 divided by 3
minus 1 by 3.
minus 1 by 3, right? So it has come minus 1 by 3. Now here I can write, so 1 minute. I can write this equation dv by dy is equal to 4 by 3 into 1 upon y raised to 1 by 3. Like this also we can write down this equation. Now once you get this equation, now put the value of mu, and to find out this first value of mu, now here what we have to do, use the formula. हा formula आपल्याला या ठिकाणी वापरायचा आहे. Where is the eraser? Here. सगळंच गेले. इरेज केले की सगळंच गेलेली आहे.
रिपीट घ्या सर.
Okay. Once again I will repeat. Whiteboard over this given. See, what is the value of mu? 8.25.
35.
0.35.
35 twice. आता हे एसआय युनिट मध्ये करायचं आहे म्हणजे काय करावं लागेल मला 8.35 ला we have to divide it by 10.
10.
Multiplied 1 by 10. So I will write here 0.835 Newton second per meter square, right? त्याच्यानंतर इक्वेशन आपल्याला दिलेली आहे v इज इक्वल टू काय इक्वेशन आहे 2 into y raised to 2 by 3, बरोबर आहे. हे एक आपल्याला दिलेलं आहे. काय काढायचं आपल्याला टाऊ काढायचं आहे, बरोबर आहे. टाऊ ॲट y इक्वल टू 0 and tau at y equal to how much?
0.03773.
0.073.
sorry.
7. ओके. हे आपल्या या ठिकाणी टाऊची व्हॅल्यू काय काढायची, दोन व्हॅल्यू आपल्याला फाइंड आउट करायचे, बरोबर आहे. मग आता आपल्याला अगोदर काय करावं लागेल, टाऊचा आपला फॉर्म्युला माहिती आहे. व्हॉट इज द फॉर्म्युला ऑफ टाऊ? टाऊ इज इक्वल टू म्यू इंटू dv बाय dy. हा फॉर्म्युला आहे. पण आपल्याला प्रॉब्लेम मध्ये इक्वेशन दिलेली आहे, म्हणजे आपलं इक्वेशन काय करावं लागेल, या फॉर्म मध्ये आपल्याला कन्वर्ट करून घ्यावं लागेल. मग त्यासाठी काय करावं लागेल, ह्या इक्वेशनचं डिफरन्शिएशन करावं लागेल. म्हणजे काय करावं लागेल, वी हॅव टू डिफरन्शिएट दिस इक्वेशन विथ रिस्पेक्ट टू y. सो म्हणजे हे लेफ्ट हँड साईडला काय येईल मग dv बाय dy इज इक्वल टू 2 into ह्याचं डिफरन्शिएशन 2 आहे तसंच राहील. y चं डिफरन्शिएशन काय येईल, सी हियर कुठे असेल x रेस टू n, जर याचं डिफरन्शिएशन करायचं असेल तर याचं डिफरन्शिएशन काय येईल n into x रेस टू n minus 1 हे त्याचं डिफरन्शिएशन असतं, बरोबर आहे. मग आता हे y चं जे 2 पॉवर आहे 2 by 3 इट विल कम ॲज इट इज हियर इनटू y रेस टू आता n काय या ठिकाणी 2 by 3, सो 2 by 3 minus 1, बरोबर. मग या ठिकाणी काय येईल, हे 2 by 2 4 divided by 3 y raised to हे 2 by 3 minus 1 is nothing but here it will become minus 1 by 3. So y ची पॉवर काय या ठिकाणी minus 1 by 3. आता हे y raised to minus 1 by 3 ह्याला आपल्याला कसं लिहिता येईल 4 by 3 into 1 upon y raised to 1 by 3, बरोबर आहे का. हे खाली गेल्यानंतर याची पॉवर काय होईल, प्लस होईल, बरोबर आहे. ह्याला वरती घेतलं तर आपण याची पॉवर मायनस लिहिता येईल, हे आपल्याला असं पण लिहिता येईल. सो दिस इज व्हॅल्यू ऑफ dv बाय dy. हे आपल्याला dv बाय dy आपल्याला या ठिकाणी भेटले. मग आता काय करायचं, हे dv बाय dy ची जी व्हॅल्यू आहे त्या इक्वेशन मध्ये टाकून द्या. या इक्वेशनला नाव द्या इक्वेशन नंबर 1. मग आपल्याला टाऊची इक्वेशन काय भेटली, मग tau is equal to mu into 4 by 3 into 1 upon y raised to 1 by 3. Okay. So like this, you will get the value. Now put this values of mu. Mu ची value किती आहे? 0.835 into 4 by 3 into 1 upon
0 ठेवायचं ना y0 ठेवायचं ना सर
hmm?
y0 ठेवायचा का
येस y ची व्हॅल्यू 0 ठेवायची त्या ठिकाणी. मग इथं काय येईल या ठिकाणी? y ची
0 येते
व्हॅल्यू
तिथं
0 रेस टू एनिथिंग इट विल बिकम 0. हे पण 0 येईल.
इन्फिनिटी येते सर तिथं.
हा मग आपलं उत्तर याचं लिहून टाकायचं. मग टाव इज इक्वल टू इन्फिनिटी. याचं आपलं उत्तर काय आलं पाहिजे? ऍट y इक्वल टू 0 शिअर स्ट्रेसची व्हॅल्यू टाव इज इक्वल टू इन्फिनिटी. सो दिस इज द फर्स्ट आन्सर. सेकंड, आता ह्या y च्या जागी काय टाकायचं तुम्हाला? 0.073.
0
हा put this value instead of this y 0.073 and find out the answer. Tell me the answer.
2.64.
हा 2.64
Unit
न्यूटन पर मीटर स्क्वेअर.
Newton per meter square. Correct. So now let us check whether our answers are correct or not. First answer is infinity and second answer is 2.64. So I will come back here. Okay, so tau is equal to पहिलेचं उत्तर आहे infinity, second उत्तर आहे या ठिकाणी 2.64 Newton per meter square. Correct. So our answers are correct. See here, ज्यावेळेस एखादा फ्लुइड फ्लो होत असतो, एखाद्या सरफेसला त्याची सगळ्यात खालची जी लेअर असते किंवा सरफेसला चिटकून जी लेअर असते, सपोज दिस इज द सरफेस आणि याच्यावरती लिक्विड फ्लो होतोय. ठीक आहे. सगळ्यात खालची जी लेअर असते सरफेसला चिटकून असलेली, त्या लेअरवरती सगळ्यात जास्त रेजिस्टन्स वापर होतो. कारण सरफेसचा रफनेस जो आहे, त्या रफनेसमुळे काय होते, सगळ्यात खालची जी लेअर आहे ती ह्याला चिटकून राहते. ओके, इट विल हॅव द व्हेलॉसिटी 0 अँड आपला अशा टाईपचं प्रोफाईल आपल्याला या ठिकाणी पाहायला भेटतो. ओके, ओपन चॅनलमध्ये. आणि ह्याच्यामध्ये पाईप फ्लोमध्ये या अशा टाईपचा पॅराबोलिक कर्व आपल्याला पाहायला भेटतो. ठीक आहे. मग ज्यावेळेस y ची व्हॅल्यू 0 असेल, y ची व्हॅल्यू 0 म्हणजे काय? एकदम सरफेसला चिटकून त्या ठिकाणी जो लेअर आहे त्या ठिकाणी शिअर स्ट्रेसची व्हॅल्यू काय भेटेल आपल्याला? इन्फिनिटी. जसं आपण इथून वरती जायला लागेल तसं तसं काय लागेल या ठिकाणी ही व्हॅल्यू या ठिकाणी काय झाली? कमी झाली. इन्फिनिटीपेक्षा खूप कमी व्हॅल्यू आली. परत अजून थोडं वरती गेलो तर अजून आपल्याला कमी व्हॅल्यू भेटेल. ओके, इन दिस वे द व्हॅल्यू ऑफ शिअर स्ट्रेस इट विल गो ऑन डिक्रीजिंग इन दिस डायरेक्शन. ओके, so now here time is about to finish. Let me take your attendance and then you can leave the session. Okay, I will stop the recording.